B. Janardhan Reddy. In this video, I am going to tell you about the electronic configurations of the atoms from atomic number 21 to 30. First, I will show you the samples of these elements with their names and symbols. See here, Scandium Sc, Titanium Ti, Vanadium V, Chromium, its symbol is Cr, Manganese Mn, Iron Fe. The Latin name of iron is ferrum. Its symbol was derived from its Latin name. Okay. Cobalt Co, nickel Ni, copper Cu. The Latin name of copper is cuprum. Its symbol was derived from its Latin name. Okay. And zinc Zn. So these are the 10 elements whose electronic configuration I am going to explain now. Okay. Now, what is electronic configuration? The distribution of electrons into orbitals of an atom is called its electronic configuration. If one keeps in mind the basic rules which govern the filling of different atomic orbitals, the electronic configurations of different atoms can be written very easily. However, I already explained these basic rules which govern the filling of different orbitals in my previous video while writing the electronic configurations of the first 20 elements in the periodic table. Okay, so electronic configuration is nothing but the distribution of electrons of an atom into orbitals is called its electronic configuration. Okay. Let us see here the increasing order of the energy of the orbitals. So orbitals are filled in this order only. So the energy of 1s orbital is less than 2s orbital and the energy of 2s orbital is less than 2p orbital, like this. According to Hofbauer principle, in the ground state of the atoms, the orbitals are filled in order of their increasing energies. I already explained all these basic principles in my video, in my previous video. Okay, so here also I am showing you the increasing energies of the orbitals. You can see here 1s orbital, it has the lowest energy, and above that we have 2s orbital, above that 2p orbital. In this order only orbitals are filled by the electrons. Next 3s, 3p, 4s, 3d, 4p, 5s, isn't it? In this order only. After filling 5s, electrons enter into 4d. Next they enter into 5p, 6s, like that. Okay. So this is the order of filling the orbitals, atomic orbitals. Okay. Now let us write the electronic configuration of scandium. Name of the element is scandium. Its atomic number is 21. Number of protons 21. Number of electrons 21. And The nucleus of scandium has 21 protons and 21 electrons revolve around this nucleus. Okay, so see here, first orbit, it can accommodate a maximum of 2 electrons only. In the second orbit we have 8 electrons. Third orbit there are 9 electrons are revolving, and in the fourth orbit, that is in the fourth main shell, we have 2 electrons. So totally 21 electrons are revolving around the nucleus of scandium. Now we have to fill these electrons into various orbitals following the basic rules. Okay, see here, the first electron, this one, enters into 1s orbital. Second electron pairs up with this electron, that is 1s orbital is completely filled. Next 2s. Once 2s orbital is completely filled, electrons enter into 2p orbital. So the fifth electron occupies one of the empty orbitals of 2p. See here. Okay. Now the sixth electron will not pair up with this electron. Instead, it will occupy another empty orbital according to Hund's rule. According to Hund's rule, if same energy orbitals are available, if more than one equi-energy orbitals are available, all these equi-energy orbitals are singly filled at first, then they are doubly filled. That is, pairing will be taken place once all these orbitals are singly filled. So the sixth electron will occupy this orbital, this empty orbital. Okay, seventh electron occupies the other empty 2p orbital. Okay, next pairing will be taken place. 8th electron, 9th electron, 10th electron. Okay, next 11th electron enters into 3s. 12th electron pairs up with this electron. Next, once 3s is filled, electrons enter into 3p. Isn't it? So 13th electron, 14, 15, 16th electron, 17, 18, isn't it? And after filling 3p orbitals, electrons enter into 4s. That's why these two electrons, we have to fill these two electrons into orbitals. Okay. Nineteenth electron occupies 4s orbital, and 20th electron, this one, pairs up with this electron. Okay, so this is the 21st electron, that is differentiating electron is 21st electron. The differentiating electron is the 21st electron that enters into 3d orbital. There are 5 equi-energy 3d orbitals. All these 3d orbitals are singly occupied at first, then pairing will be taken place. So this electron will occupy one of the empty 3D orbitals. Okay. Now, what is the electronic configuration you see here? In 1s there are 2 electrons, in 2s there are 2 electrons, in 2p there are 6 electrons, in 3s 2 electrons, in 3p 6 electrons are there, and in 4s 2 electrons are there, and in 3d 1 electron is there. Okay. This is the electronic configuration of scandium, or in short way we can write the electronic configuration of scandium as argon 3d14s2. That means before this 3d14s2 argon electron configuration is there. Up to this it is nothing but argon electronic configuration, inert gas element argon. Okay. This is the electronic configuration of scandium. Next element is titanium Ti, atomic number 22. That means the nucleus of titanium contains 22 protons and 22 electrons revolve around the nucleus. Number of protons is equal to 22, number of electrons 22, and 22 protons are there in the nucleus. 22 electrons revolve around the nucleus in different shells. See here. So first orbit contains 2 electrons, second orbit contains 8 electrons, third orbit contains 10 electrons, and the fourth orbit has 2 electrons. Totally 22 electrons are there. We have to fill these 22 electrons into these orbitals as above. Okay. First electron, second electron, 3, 4, 5, 6, seventh electron, 8, 9, 10. 11th electron, 12th electron, 13, 14, 15, 16, 17th electron, 18th electron. After filling 3p, electrons enter into 4s. 19th electron, next 28th electron. So 20 electrons have been filled so far. Next, we have already seen the 21st electron enter into one of the empty 3D orbitals, and the differentiating electron, that is the last electron, is 22nd electron, isn't it? It occupies the other empty 3D orbital. Okay, so in this way the electronic configuration, isn't it, 1s2, 2s2, 2p6, 3s2, 3p6, 3d2, 4s2, because in 3d we have 2 electrons, isn't it? So in short way we can write this electronic configuration as argon 3d2 4s2. Okay. Next, vanadium V, atomic number 23, number of protons 23, number of electrons 23. 23 electrons are revolving around the nucleus of vanadium. First orbit contains 2 electrons, second orbit has 8 electrons, and third orbit has 13 electrons, isn't it? So here I have shown these electrons, that is the electrons which are going to fill 3D orbitals, have been shown a little bit bigger in size. Okay. Next, fourth orbit contains 2 electrons. So totally we have 23 electrons. Let us fill these electrons into different atomic orbitals. 1s is filled at first, 2, 3, 4, 5, 6, 7, 8, 9th electron, 10th electron. Next, after filling 2p orbital, electrons enter into 3s, 11th electron, 12th electron, 13, 14, 15, 16, 17, 18, 19, 20, isn't it? And these 3 electrons which are revolving in the third main shell, they enter into 3D orbital. It occupies this orbital, empty orbital, second empty orbital. So 23rd electron is the differentiating electron, that is the last electron, and it occupies the other empty orbital. Okay, so what is the electronic configuration you see here? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d3. You can write 4s2, 3d3 also, but I have written in systematic order. Okay, or we can write this electronic configuration in the short form as argon 3d3 4s2. In 3d subshell we have 3 electrons, and in 4s we have 2 electrons. Before this, argon electronic configuration is there. From here to here, it is the electronic configuration of argon, an inert gas element. Okay. The next element is chromium. Before going to write the electronic configuration of chromium, we should know the stability of completely filled and half-filled subshells. Chromium Z equal to 24, that is its atomic number is 24, and copper Z equal to 29, its atomic number is 29. These two atoms have abnormal electronic configurations. In order to know their abnormality in electronic configuration, we should know the stability of completely filled and half-filled subshells. You see here. The ground state electronic configuration of the atom of an element always corresponds to the state of the lowest total electronic energy. That means we are writing the electronic configurations of the atoms when they are in their ground state. When an atom is in its ground state, it will have the lowest total electronic energy. Okay? So the electronic configurations of most of the atoms follow the basic rules, that is Higgs principle, Pauli's exclusion principle, and Hund's rule. These are the rules which govern the filling of the atomic orbitals. I already explained very clearly about these rules in my previous video while writing the electronic configurations of the first 20 elements in the periodic table. Okay, so however, in certain elements such as chromium or copper, where the two subshells 4s and 3d differ slightly in their energies, an electron shifts from a subshell of lower energy, that is 4s, to a subshell of higher energy, that is 3d, provided such a shift results in all orbitals of the subshell of higher energy getting either completely filled or half filled. That means if an atom has completely filled d orbitals or half filled d orbitals, then it has been found that there is extra stability associated with those electronic configurations, isn't it? So in order to get extra stability, chromium and copper will have the abnormal electronic configurations than usual ones. See here. In this way, the electronic configurations of the elements chromium Cr and copper Cu adopt the D5 and D10 configurations. D5 means half filled d orbitals. D10 means completely filled d orbitals. Isn't it? So chromium will get D5 configuration, isn't it? From shifting an electron from 4s to 3d. Similarly, copper will get D10 electronic configuration by shifting an electron from 4s to 3d. Isn't it? So in this way, these two atoms, that is chromium and copper, have the abnormal electronic configurations than usual ones. In order to get some extra stability, these two atoms will acquire this type of electronic configurations. Okay, so let us see here. Now let us write the electronic configuration of chromium Cr. Atomic number is 24, number of protons are 24 and number of electrons are 24. So the nucleus of chromium contains 24 protons and 24 electrons revolve around this nucleus in different orbits. This is the first orbit, n equal to 1. It contains 2 electrons. N equal to 2. Second orbit contains 8 electrons. And there are 14 electrons revolving in n equal to 3. That is in the third shell. Next, in n equal to 4, there are 2 electrons. Actually, these 2 electrons belong to 4s orbital. Okay. Now, let us fill these electrons into various atomic orbitals as usual. See what happens. First electron enters into 1s orbital. Second electron will pair up with this electron. Third, fourth one. Fifth electron occupies one of the empty orbitals of 2p. Sixth one. Next, seventh one. From 8th electron onwards, pairing will be taken place. 9th electron and 10th electrons. So 2p orbital has been completely filled. Then the 11th electron enters into 3s. Then 12th electron pairs up with this electron in 3s, then electrons enter into 3p, 13, 14, 15, okay, 16, 17, 18. Next 19 electron enters into 4s and 20th electron pairs up with this electron. So 4s orbital is completely filled. Once 4s orbital is completely filled, electrons enter into 3d. Next 21st electron occupies one of the empty orbitals of 3d. 22nd, 23rd and 24th. Okay, so observe very carefully here. Here there are 4 electrons in 3d orbitals, 3d subshell. Okay, so the electronic configuration of chromium is, here I am writing, electronic configuration should be 1s2, 2s2, 2p6, 3s2, 3p6, 3d4, 4s2. This should be the electronic configuration, but it is wrong, isn't it? In order to get extra stability, chromium shifts an electron from 4s to 3d empty orbital here. Then chromium will have d5 configuration. That means all the 3d orbitals are half filled. When d orbitals are half filled or completely filled, the atoms will get some extra stability. So chromium, this is the usual electronic configuration, but it is wrong, isn't it? So the 4s electron, one of the 4s electrons shift into 3d empty orbitals. You see here, I am taking this electron back here. So this electron comes to 3d, that is, it jumps into third shell. You see here, okay, now it is revolving. So this electron enters into the other empty 3d orbital. That's all. So in this way, chromium has half-filled 3d orbitals. When half-filled 3d orbitals or completely filled 3d orbitals are available, then the atoms will get some extra stability. Okay, so the electronic configuration of chromium is now 1s2, 2s2, 2p6, 3s2, 3p6, 3d5. d5 configuration it is following 3d5 and 4s1. Or the short way we can write it as argon 3d5 4s1, isn't it? So chromium has abnormal electronic configuration because of this reason explained. Okay. Next element is manganese Mn. Its atomic number is 25. There are 25 protons and 25 electrons. These are the electrons. Totally 25 electrons are revolving around the nucleus of manganese. Okay, so let us fill all these electrons as usual into the atomic orbitals. 1, 2, third electron, fourth electron, 2s is completely filled, electrons are entering into 2p 2p subshell is being filled now. Next electron. Next. So totally 10 electrons have been filled so far. The 11th electron enters into 3s, 12th electron, 13, 14, 15, 16, 17 and 18th electron. Okay, next 19th electron enters into 4s and 20th electron will pair up with this electron. Now 5 electrons are revolving in third orbit and all these 5 electrons will enter into 3D subshell, and all these 5 electrons occupy empty orbitals. Okay, according to Hund's rule, all orbitals are singly filled at first, then pairing will be taken place. Okay, so then what is the electronic configuration of manganese now? 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s2, or in the short way we can write it as electronic configuration argon 3d5, 4s2. That is, before 3d5, 4s2, argon electronic configuration is there. Okay, and the next element is iron, ferrum. Atomic number is 26. 26 protons are there and 26 electrons are revolving around the nucleus. Okay, now see here, totally 26 electrons are there. First electron, second electron, next 2p is filled, then pairing will be taken place now. Two p orbital is complete, 2p subshell is completely filled, then electrons are entering into 3s. 3s is completely filled, then 3p is being filled now. Okay, so totally 20 electrons have been filled so far. Now 6 electrons are there and these 6 electrons are in third shell. So they enter into 3D orbital, 3D subshells. Okay, 3. Okay, so 25 electrons have been filled so far. Now the differentiating, that is the last electron, is 26th electron. So 26th electron will pair up with this electron, that is, pairing will be taken place now. So in this way, in 3D subshell, how many electrons are there? 6 electrons are there. Okay, so 3d6, 4s2, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Okay, so in the short way we can write it as argon 3d6, 4s2. The next element is cobalt. Its atomic number is 27, number of protons 27, number of electrons 27. So the nucleus of cobalt contains 27 protons and 27 electrons are revolving around the nucleus in different orbits. First orbit, second orbit, third orbit and fourth orbit. Okay, so 2 electrons are there in the first orbit, 8 electrons are there in the second orbit, and 15 electrons are revolving in the third orbit, and 2 electrons are revolving in the fourth orbit. So totally 27 electrons are there. Let us fill these electrons into various atomic orbitals. 1s is filled, next 2s, fifth electron enters into 2p, 2p is completely filled, then electrons are entering into 3s orbital. So once 3s orbital is completely filled, then they enter into 3p orbitals. So totally 18 electrons have been filled, okay, so far. Next 19th electron, that is from n equal to 4, because 19th electron is there, 19th and 20th electrons are there in n equal to 4. So the 19th electron enters into 4s orbital, 20th electron has paired up with this electron. Now how many electrons are there? You see here 1, 2, 3, 4, 5, 6, 7. 7 electrons are revolving in third orbit. Let us fill these electrons into 3D. 21st electron, 22nd, 23rd, 24th, 25th electron. All d orbitals are singly filled, that is half filled. Then according to Hund's rule, pairing will be taken place. 26th electron, and the differentiating electron is 27th electron, which enters into this orbital. Okay, so what is the electronic configuration now? It is 1s2, 2s2, 2p6, 3s2, 3p6, 3d7, because in 3d there are 7 electrons and 4s2. Clear? So, or in the short way, we can write it as argon 3d7 4s2, isn't it? The next element is nickel Ni, 28 atomic number, 28 protons and 28 electrons. 28 protons are there in its nucleus. 28 electrons revolve around the nucleus in different shells. First shell or first orbit contains 2 electrons. Second orbit has 8 electrons. Third orbit contains 16 electrons totally. And fourth orbit has only 2 electrons. So totally 28 electrons are there to fill into different atomic orbitals. First electron enters into 1s. Second electron, okay, so this one is the 19th electron, and 20th electron pairs up with these electrons. Totally 20 electrons have been filled into different atomic orbitals. Next, how many electrons are there to fill? See here, 3, 4, 5, 6, 7, 8. 8 electrons are there, and these 8 electrons will enter into 3d orbitals. 21st electron, 22nd electron occupies one of the empty orbital. 23rd electron occupies another empty orbital. 24th electron occupies another empty orbital. 25th electron occupies the last empty orbital. Then pairing will be taken place. 26th electron pairs up with this electron here. Next 27th electron, and the discriminating electron is the 28th electron. It pairs up with this electron. So totally 28 electrons have been filled. The electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d8. The same I have written here, or you can write it in the short way as argon 3d8 4s2. Clear? Next, the next element is copper, Cu. Its atomic number is 29, number of protons are 29, number of electrons are 29, and 29 protons are there in its nucleus. 29 electrons are revolving around the nucleus. First orbit contains 2 electrons, and the second orbit 8 electrons are revolving, and in the third orbit, isn't it, 17 electrons are revolving, and in the fourth orbit there are 2 electrons. Okay, so let us fill all these electrons into various orbitals. Second electron, third electron, fourth electron, fifth electron, sixth electron, seventh electron. Next pairing starts. 10th electron. Next 3s. 11th electron. 12th electron. 13th one. 14th electron. 15th electron. 16th electron. 17th electron. 18th electron. 19th electron enters into 4s. 20th electron. So totally 20 electrons have been filled so far. Still how many electrons are there? Check. There are 1, 2, 3, 4, 5, 6, 7, 8. 9 electrons are there still. So 21st electron enters into 3d orbital. Next 26th electron, 27th electron, 28th electron and 29th electron. So in this way, if you write the electronic configuration of copper, it is 3d9. See here, 1s2, 2s2, 2p6, 3s2, 3p6, 3d9, 4s2. But it is wrong. So in order to acquire extra stability, copper shifts an electron from 4s into 3d. Then copper will have all the completely filled d orbitals. So when an atom has half filled d orbitals or completely filled d orbitals, it acquires extra stability. Okay, so this configuration is wrong in this case. So let us see here. So let us take this electron back into its position. It was there in 4s, and this electron jumps into third orbit, and this electron enters into 3d orbital. It pairs up with this electron. Then copper has all d orbitals completely filled, isn't it? So the electronic configuration of copper is like this: 1s2, 2s2, 2p6, 3s2, 3p6, 3d10 and 4s1. Or argon 3d10 4s1. And the last one is zinc. Atomic number is 30. 30 protons, 30 electrons, isn't it? See here, 30 electrons are revolving around the nucleus. First shell contains 2 electrons, second shell contains 8 electrons, and third shell contains 18 electrons, whereas the fourth shell contains 2 electrons. Okay, so let us fill all these electrons into various atomic orbitals. Okay, 21, 22, 23, 24, 25, 26, 27, 28th electron, 29th electron, and the differentiating electron in copper is 30th electron that pairs up with this electron here. So totally 30 electrons have been filled. So the electronic configuration of zinc is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, or argon 3d10, 4s2. Okay. So these are the electronic configurations of atoms of the elements from atomic number 21 to 30, that is scandium to zinc. Okay, thank you.